Good morning, everyone. Today in the conic section we are going to talk about ellipse, right? In the previous video we have seen the parabola. Now we are going to talk about ellipse, right? So first of all, let us see that what is the structure of ellipse. We can take a cone, right? This is a cone, and this cone, if we talk at some angle with the base, if we cut this cone at some angle with the base, right, not parallel to the base, we are going to cut this cone not parallel to the base but at some angle with the base. So when we cut this cone at some angle with the base, then we will get some shape like somehow like this. We will get a shape of this type, right? This is this shape. If I draw it separately, then maybe the shape will be somehow like this. This is what we will get when we cut the cone at some angle with the base. And this kind of shape, normally we call it as oval shape, and in mathematics we call this as ellipse. Is it okay? So this is the basic look of ellipse. Is it okay? Now, unlike parabola, in the parabola, to draw a parabola, we required a fixed point and a fixed line, right? The fixed point we named as focus, and fixed line we named as directrix. In the case of ellipse, we will have again the fixed point, but this time there will be two fixed points. One will be at this point and another will be at this point. So these are the two fixed points here, and we will call this both as focus. Is it okay? And then since we have two focus, so we will also get two directrix. This will be one directrix and this is another directrix. Is it very clear? Now, in the case of parabola, what happened is when we took a point somewhere on the curve, right? We named it as P, right? And then join it with the focus. This focus, maybe we can name it as S1, and this focus we can name as S2, right? When we join it with this point, with the focus, and then drop a perpendicular from P to the directrix, right? The condition that we got in the case of parabola was that this PS was equal to PM, right? But in the case of ellipse, it will be different. In the case of ellipse, the ratio of this PS1 and then PM, these two distances are not same, but the ratio of these two will be always a constant, right? This is somehow like geometric progression. If you remember, in the geometric progression, you had the term as 2, 4, 8, 16, and so on, right? In the case of GP, the ratio of any two consecutive term was always same, and we call that ratio of the two consecutive term as common ratio. You take any two term, the ratio of the two consecutive term will be always same. So somehow that kind of condition arises here in the case of ellipse. The ratio of this PS and PM will be always constant, right? And this constant we call it as eccentricity. This constant is called as eccentricity, right? And this eccentricity we can denote it by notation E, by a letter E. Is this very clear? So this is the basic talk about this is the basic thing about the parabola, about ellipse, is that in the ellipse we will have two focus and then we will have two directrix, and the ratio of this PS1 to PM will not be same. The distance of these two will not be same, but the ratio of these two will be always same, and it will be equal to a constant quantity. That constant quantity we name it as eccentricity, and we can denote it by small e. Is it okay? Now we will look at some of the other component of ellipse. Now we are going to see some other component of ellipse, and we will try to understand the detailed study of ellipse. Here we are not going to do any derivation like parabola, but we will try to understand the component of this ellipse. So let us have the ellipse right? This is ellipse, and then this is the coordinate. Sorry, my lines are not very straight. These are the two coordinate. Is this okay? And the point of intersection of these two coordinate, we can mark it as origin. This is, say, this is origin, right? Origin is all the counting will start from this point only. Towards the right side, on the x-axis will be positive, this side negative. Again, along the y-axis in the upward direction will be positive, and downward direction it will be negative. We are already mindful of that. We are aware of the number line, right? Now, we have the focus here. One focus is here, another focus is here, right? We can name this as S1, and this focus we can name as S2. Is it okay? Now, since this point is origin, so we can mark this as 0, 0. The coordinate of this origin will be equal to 0, 0. Is it very clear? Now Now here, this parabola, it cuts the x-axis at 2 points. One is this point, another is this point. Is it okay? The parabola, sorry, the ellipse cuts the x-axis at 2 points. This is 1 point and this is the another point, right? These 2 points are called as the vertex. These are called as vertex. This is also vertex. Now, along the y-axis, also this ellipse cuts the y-axis at 2 different points, right? These are the 2 points, and then these 2 points are called as co-vertex. This is not very important, just for information I am sharing this. This is called as co-vertex, and this also will be called as co-vertex. Is it very clear? Now what happens is the distance from this point till this point, the distance from this point till this point is called as major axis. Is called as major axis. We can call this as major axis. Major axis, right? And the distance from this point till this point, right, along y-axis, this is called as minor axis. This is called as minor axis, right? After this, now this point, this focus S2 is at a distance of C from the origin, at a distance of C from the origin, right? This is exactly the center. This point is exactly the center, right, from S1 and S2, or from the vertex, from the two vertex. This is exactly at the center, right? And this S2 focus is at a distance of A, and this also will be at a distance of A. Well, remember here, when I talk about the left hand side, I am talking about the distance. That is why I am not mentioning the sign. Okay. Now, since this S2 is at a distance of A, at a distance of C from the center, therefore the coordinate of this point will become C0, and the coordinate of this point will be, now this time we are writing the coordinate, so we have to write the negative sign, so negative C and 0. Is it okay? Now the length of the major axis has to always equal to 2a, right? This is because this point is at a distance of A from the center, and this also is at a distance of A from the center, and therefore the coordinate of this vertex will become A0, and then the coordinate of this will become negative A and 0. That means the coordinate of the two vertices are clear. Now this co-vertex, these two co-vertex is at a distance of B from the center. Therefore the coordinate of this will become 0B, right? Because this is on the y-axis, where x will be always 0. Therefore the first coordinate is 0 and second coordinate is the distance from the origin. So likewise, the coordinate of this will become 0 and negative b. Is it clear? Now the next thing that we have is the distance between S1 and S2. This S2 is at a distance of C from the center, and this focus S1 is at a distance of C from the center. That means the total distance between the two will become equal to 2C. And the distance between the two foci, the foci is the plural of focus, right? Somewhere you can hear this foci as foci. Some teachers call this as foci, but actual pronunciation, if you look into the dictionary, you will see that the plural of foci, the focus is foci, right? And then this distance will be equal to 2c. The distance between the two focus is called as focal distance. Is called as focal distance. The distance between the two foci is called as focal distance, and it is denoted as 2c. Focal distance is equal to 2c. Is this very clear? Now, these are the things that we need to remember. What is the coordinate of the vertex, major vertex? What is the coordinate of the minor vertex? Right? What is the coordinate of the focus, S1 and S2? Is it okay? And these things I'm also going to show you in terms of table. Now, on top of all these things, we also need to know that we are using here A, B, and then C. There are three letters that we are using here in this. A, B, and C. So there is a relation between A, B, and C, and that relation is A square is equal to B square plus C square. This is very important result. Please, we need to keep in mind. You can take a note of this relation. A square is always equal to B square plus C square. Is it okay? Whereas this C is equal to AE. C is equal to AE. This is another very important result that we need to keep in mind, right? Where E is the eccentricity. E is the eccentricity. We know what is the C. We also know what is A. A is the distance of the vertex from the center. C is the distance, right, of the focus from the center. And E is the eccentricity. So there is a relation between A, C, and E. C is equal to AE. From here, if we want, we can also have the value for E. That will become C over A. And this also we use quite often. In the numerical, we are using all this result. I hope this is very clear. Now I am going to show you the table. Now we will talk about the types of ellipse. Same like a parabola. Parabola used to be of 4 types. Ellipse we have of 2 types, right? And then I will show you the values of different components. Now you can look at the board, right? On the board you can see you are given a table, right? This table describes about the different component of the 2 different type of ellipse. In the column, the first column, in the table in the first column you can see you have the equation of the ellipse as x square over a square plus y square over b square is equal to 1, right? This first column, it gives you the information about the horizontal ellipse. The ellipse that I drew on the board before, this talks about that horizontal ellipse, right? When the major axis is along the x-axis, right, then we call that ellipse as horizontal ellipse, right? And the equation of that ellipse is x square over a square plus y square over b square is equal to 1. Another column, the last column we have is about the vertical ellipse. That means when the major axis is along the y-axis. I hope I am able to make you clear. When the major axis is along the vertical, when the major axis is along y-axis, then we call it as vertical ellipse, right? So in this table, you are able to see the value of different components. Like we have the coordinate of the center. The center is always same, right? 0, 0. The coordinate of center for any of the ellipse will be same, 0, 0. Then coordinate of foci, as you can see, it is plus minus AE and then 0. If it is horizontal, and if it is vertical, then the value will swap. The x will become y and y will become x. And this AE is also equal to E. So sometimes the coordinate of foci, we can also write this as plus minus C0, right? And then for the vertical, it will become accordingly 0, comma, plus minus C, because the value of C is equal to AE, right? So this is the table that you need to have always in front of you when we are solving the question. We don't need to memorize. If you go on memorizing this table, then the question will become quite hectic. So we don't need to memorize this table, but yes, whenever we solve the question, we must keep this table in front of us, and then we should solve the question, right? So we will now see some few questions. We are going to start with question number 1. This question number 1, it says find the eccentricity of the ellipse. The question is to find the eccentricity of the ellipse of which the major axis is double of minor axis. Major axis is double of minor axis. Is it clear? So with the given instruction, we will try to find the eccentricity. The question is to find the eccentricity when the major axis is double of the minor axis. So we can start the solution. According to question, right, the major axis is double of minor axis. We know that the major axis is 2a, and the question is, this is 2 times more than the minor axis, and minor axis we can denote it by 2b. Right? This is the information according to the question. Now let us simplify. These two will cancel these two, and then we are left with a is equal to a is equal to 2b. Right? Now I gave you a relation between a, b and c. Right? The relation we can see here, since a square is equal to b square plus c square. Now this is the relation that we know. So in order to use this relation, we are going to make some change in this result, and here we will square on both the sides. So squaring both the sides, both the sides, what do we get is, this will become a square and this will become 4b square. Hope I could make it clear. A square is equal to 4b square. Now, using this formula, a square is equal to what? B square plus c square. Right? So, can we replace this a square by the sum of this b square plus c square? So, if we do so, this becomes what? B square plus c square is equal to 4b square. Is it okay? Now, in this we can see here, this b square and this 4b square are like term. So, we will simplify. This becomes c square is equal to 4b square minus b square, and this will be equal to 3b square. So c square is equal to 3b square. Right? Now what we can do is, because we know that c is equal to ae. Right? Now in this c square is equal to 3b square, I'm going to replace this c by ae square. So we can write this as ae whole square. That means we will square this both. A square e square is equal to 3b square. Please be mindful, the question is to find the eccentricity. So now we are going to find the value of eccentricity, that is e square. Right? Now this implies our e square will become equal to 3b square over a square. This e square is equal to 3b square over a square. Right? Now to find the value of e square, we are going to replace this a square, a with a is equal to 2b. We know that a is equal to 2b, right? So we can write this as e square is equal to 3b square, and this is divided by a is equal to 2b. So 2b, and then you have to square. So this is a square. This will finally become 3b square over 4 and then b square. Alright, this b square and this b square is cancelled. We are left with 3 over 4. Now to find the value of e, this square will be shifted to the other side. So this is going, the square goes to that side, means your answer will be plus minus root over 3 over 4. Right? And as you know that 4 is a perfect square number, so that part will come out, and your final answer will be equal to e is equal to plus minus root over 3, and then down denominator will be 2. This is the final value of your eccentricity. Is it clear? Now we are going to take question number 2. This question number 2, it says that if the minor axis of an ellipse, is equal to the distance between the foci, now we are moving on to question number 2. This question number 2, it says, if the minor axis of an ellipse is equal to the distance between its foci, prove that its eccentricity is equal to 1 over root 2. Once again, see the question. If the minor axis of an ellipse is equal to the distance between its foci, minor axis. Minor axis is equal to the distance between the foci. If it is so, then prove that eccentricity is 1 over root 2. Right? This is question number 2. So, here we can solve the solution with the given information. Solution according to the question. Right? What it says is that the minor axis is equal to the distance between the two foci. Distance between the two foci is called as focal distance, right? And focal distance we have seen it is denoted by 2c. So then we can write this as the distance between the minor axis is equal to the distance between the two foci, that is 2b is equal to 2c. 2b is equal to 2c, right? Now, accordingly, from here we can find the value of b and c. There is a relation between b and c. We will get this as b is equal to c. We got this result, b is equal to c. Now, we have to prove that, the question is to prove that eccentricity, let us have this result here, eccentricity is equal to 1 over root 2. This is what we have to prove. Is it okay? So, what we are going to do here is, c, right, we need to, this is right now we got the result as b is equal to c, right, and we have to prove that e is equal to 1 over root 2. That means how can we introduce this e, right? We need to have e in the equation, then only we can find its value. So this is c, we know that its value is equal to ae, right? So we will write here c can be replaced as ae is equal to b, right? We know because since c is equal to ae, with this fact we have replaced this c by ae, right? And from here we can have this e as equal to b over a. B over a. Is it okay? Now we know what is a. We also have information. We also know that a square is equal to b square plus c square, right? We know this result. From here we can have the value for a, and therefore we can write this as a is equal to root over b square plus c square, right? Let us put it here. So this will come as equal to e is equal to b over a, we can write as equal to b square plus c square, isn't it? Now you have to keep this in your mind that this is your target, right? By any means we have to get the value of e as equal to 1 over root 2. So what we can do is, we are getting this result. Now we have already generated our result as b is equal to c. So we are going to replace this b by c, right? We are just going to replace b by c or c by b, right? So numerator, because we have b, so why not we replace this c by b then, right? So if we replace it, this b as keep as it is, root over this b square also will be as it is, and this c will be replaced by b because c and b both are same. So here we are going to replace this c by b. So since it is c square, therefore we can have this as b square. Now this b square and this b square both are like term, we can add it, and therefore we get this as b over root over b square plus b square will become 2b square. Now in this 2b square, 2 is a non-perfect square number, it will remain under the radical sign, and b square is a perfect square number, so this will come out of the root sign, and therefore your result will be b over, this is b and this is root of 2. Now this b and this b is cancelled. Finally we got the result what was required, and therefore the answer is e is equal to root over 2. This we got the result. Hope the question is very clear. Now the next question we are going to take is question number 6. Question number 6. First of all we are going to take question number 6a. Question number 6a, it says that find the equation of the ellipse with the axis of the coordinates given so and so, right? Now if we look at a, then what is given here? First of all, let us write down the major axis is given as 6, and we denote the major axis. What is given? Given is the major axis, that is 2a. We used to denote the major axis as 2a, and this value is given as equal to 6, and the minor axis is given as equal to 4. Minor axis, that is 2b, we denote it by 2b, and this is given as equal to 4, right? With the help of these two information, we have to write down the equation of the ellipse, right? Now as you have seen the table, and please keep the table in front of you. In the table, you can see that we have two types of ellipse. One is the horizontal ellipse, and then another is the vertical ellipse. In the horizontal ellipse, you might have noticed that the A was below X and B was below Y, and A was greater than B, right? So when A is greater than B, right? If, or in the simple way, we can say like if the bigger quantity comes below X, that means this represents the horizontal ellipse, and if the bigger number is under Y, then that will indicate the vertical ellipse. Hope I am able to make it clear. When the bigger number falls under X, it will represent horizontal ellipse, and if the bigger number falls under Y, it indicates vertical ellipse. Is it very clear? So here, now when you calculate the value of A and B, you will be able to predict that what kind of ellipse is this, right? So A value is equal to 2 will come to right side, so 6 divided by 2 will become 3, and B will be equal to 4 divided by 2 is equal to 2. Now you can see here your A is greater, and that is going to be under X, right? Then we will take this ellipse, then our ellipse is going to be horizontal ellipse. Horizontal ellipse. Now we are going to start writing the equation. So for the horizontal ellipse, the equation of the ellipse is equation of ellipse is what? Is x square over a square plus y square over b square is equal to 1. Please be very mindful here. In every condition, we are keeping the a as the greater quantity. A as the greater quantity. Is it okay? Now, since every time we are keeping this a as a greater quantity, when this a comes below x, that means this will represent the horizontal ellipse, and if that a goes under y, then this ellipse will be vertical ellipse. Is it okay? So here this ellipse is going to be a horizontal ellipse. Now we are going to write down the equation. So by putting the value of a and b. Now x square, a is 3, so we will have the square of 3. So 3 square plus y square over b square means 2 square, and this is going to be equal to 1. Right? When we simplify this, this is x square over 9 plus y square over 4. Now these are the two fractional numbers. Let us simplify, combine, and then make this into 1. Then this way it will be, LCM will be 36, and then cross multiply 4x square plus 9y square. This is equal to 1, and therefore your final equation of the ellipse is 4x square plus 9y square is equal to 36. 36 will go to the other side, on the right hand side. It will be multiplied by 1, and therefore it will become 36. So this is the equation of your ellipse. Hope this question is very clear. Now we are taking question number 6b, right? This question number 6b is to find the equation of ellipse, right? That passes through the two given points, -3, 1 and 2 and -2, right? So this question is little different from A. Let us see how do we write the equation of ellipse when the coordinate of 2 points are given. So we are going to start the solution. Here the coordinate of 2 points are given. So first of all, let us assume the equation of the ellipse. Let the equation of the ellipse be, let equation of ellipse be, here in this case because we don't have the major axis or the minor axis, no, so there could be some confusion that this ellipse is it going to be a horizontal ellipse or it is going to be a vertical ellipse, right? So when we have such confusion, we will always start with the horizontal ellipse. Is it okay? We will just assume that this ellipse is going to be a horizontal ellipse. If it is by chance vertical ellipse also, it will automatically come out at the end that it is a vertical ellipse. So we are going to start now. This is x square over a square plus y square over b square. This is equal to 1. This is what we have assumed, that let the equation of the ellipse be this one. Right? Now, this ellipse is because passing through the first point, right, whose coordinate is negative 3 and 1 means it should satisfy the equation. So we will say, we will put the value of x and y here. X as negative 3. X as negative 3. The coordinate is x minus 3 and 1. So we will take this as negative 3 square. Here for x we will put negative 3. And then when you square it, it will make it positive. So this will become 9 over a square. Now this y is 1. So y square means 1 square. So this is equal to 1 over b square. This is your equation number. This is equal to 1. And this we can name as equation number 2. Right? Now this equation is also passing through another point whose coordinate is 2 and negative 2. 2 and negative 2. Now that point also will satisfy this equation, right? So we can use a value of, for x we can take as equal to 2. So that is 2 when you put, then it will be squared and you will get this as 4 over a square. Hope you are able to understand. And then y value is minus 2. When we square that minus 2, that also will give you positive value. So this will become 4 over b square, and this is equal to 1. This is our equation number 3. Now we will solve these two equations simultaneously by elimination method, and we will try to find the value of a and b. Once the value of a and b is calculated, we can come back to the first equation, put it in the original equation and calculate it. We will get the equation of the ellipse. So now we are going to start solving it. Now this is a little different type of question, no? So what we can do is we will just keep it as it is only, and we are planning to eliminate this b, right? Therefore the coefficient of this b square has to be same. So we are going to multiply the first equation by 4. As a result, this first equation, when you multiply it by 4, that all the numerators will be multiplied by 4. So you get a new equation as 4 9s are 36 over a square as it is. Then 4 into 1 is 4. Down will be as it is b square, because we are not multiplying anything with denominator. And this will become also equal to 4. Right? So this is the new equation we have derived from equation number 2. Now to eliminate this b, we need to do subtraction. So subtraction we are doing, and now as a result these two are same, so this will be eliminated. Now we need to simplify this one. This two fraction number is going to be subtracted, because this minus this, right? That means we are going to combine this and then make it into 1. Their denominators are same, right? Their denominators are same. That means the numerator is simply going to be subtracted, directly subtracted. So this will come as minus 32 over a square, right? And right hand side 1 minus 4 will become equal to minus 3. As a result, this minus and this minus will be cancelled. We will have the value of a square as equal to 32 over 3, right? We got the value of a square. Now we want to have the value of b square. So this b square we can calculate by putting the value of this a square in any one of these two equations, because this equation is more easy. So we will put the value of a square in equation number 2. So I'm not writing the language because otherwise it will not fit in the board. So please remember, after this you need to write a sentence saying that substitute the value of a square in equation number 2. So that's what we are going to do here. This is 9 over, this 32 over 3 will come in the denominator, 32 over 3, and then plus 1 over b square is equal to 1. Alright. Now as a result here, what will happen is, now this number will be simplified and will be shifted to the other side. So your 1 over b square will be equal to, this is 1, and this quantity when it comes to this side will become negative. Now when we turn it upside down, this 9 will go, this 3 will go up, and 32 will remain down. So 9 3s are 27. That means 27 over 32. Now when we simplify these two, your final answer is coming as 5 over 32. This we got the value of 1 over b square, right? And then from here we can also have the value of b square, right? From here we can have the value of, this is the value of 1 over b square. Now we can have the value of b square. So what we can do is, both the side we will flip. We will flip both the side. As a result, what will happen? See now. Let me make the space. Now this will be flipped. So b square will be equal to 32 over 5. 32 over 5. Is it okay? Now we got the value of a square. We got the value of a square. We got the value of b square. We are going to put the value of a square and b square in equation number 1 to get the final equation of the ellipse. So let us do that. X square, a square A square we calculate the 32 over 3. So this is 32 over 3. B, then y square over this b square. This is equal to 32 over 5. And this side we have only 1. Now let us simplify. First of all, this number will flip. It will go upside down. So 3 will go up and 32 will remain down. So this equation will reduce to 3x square divided by 32. Right? And similarly, this number also will flip upside down. This will reduce to 5y square over 32. Right? And on the right hand side, we are left with 1. Now let us simplify and this make it into one fraction. Right? So we are going to take the LCM and then simplify. Denominators are same. Therefore, the numerator will be simply added, right? And the LCM will be same. So it will be 3x square plus 5y square. LCM of these both will remain as it is 32. This is equal to 1. And therefore, your final equation of the ellipse will be 3x square plus 5y square is equal to 32. This is the equation of your ellipse. Hope this is very clear. Thank you for watching the video.